Hey there, this is a California mock-up. We call California in California, which means essentially easy. But in other states, it's called an overframe or frame over. In California, we always do it on top of plywood. The reason generally we don't do a conventional roof is because we're trying to transfer some shear wall up to the diaphragm of the roof, so we have to plywood the thing and nail it off like it was a shear wall practically, and then frame a secondary roof on top. Now, coming up, we never beveled any of our sleepers. We essentially just framed this whole thing up top, threw the wood up and just started framing it. And if we were smart, we'd frame the jacks first and throw them up and then just run the ridge wild and cut it as we went along, and we left it square. But always wanted to know how to get all this stuff on the ground. And then when I finally had the skill to do so, I didn't care because it wasn't necessary. Because it really isn't necessary to have a bevel on this. It's for beauty's sake as well as a ridge. And as framers, we want to be able to run across the top of the ridges, and a lot of times they're 4x out here in California anyway. So the bevel would just make it difficult to run across the top to frame. So some guy would be up top and a guy would be down low. You know, they'd be nailing it off. But how do you achieve lengths ahead of time and the bevel of a California sleeper? And how do you, or overframe sleeper, and how do you get these two angles here? And it's pretty straightforward, and especially by the use of a framing square. One thing that's important to note is that if you look straight down on top of this in plan view, you'll see the ridge to jack rafter at a 90-degree angle, and the sleeper runs at a 45 bisects, assuming you're landing on a similar pitch roof, so a 912 to a 912 or something. But the methodology doesn't really change in terms of unequal intersecting pitch roofs, but just knowing that this is a 90-degree angle in plan view and this is a 45 will allow us to better understand how to use the framing square. Now, most framers know that a 45-degree angle on a framing square is 12-12. That's what we use generally when we're talking in terms of a hip or valley that runs diagonally at 16.97. But there's a lot of trussers that don't know that roof terminology and do a lot of overframe and want to know how to do it that way, and don't get a chance to really do beautiful stuff because they are just slamming those trusses and getting it done. So they want to break into the world, do some porches here, you know, some overframe that is nice. So one thing to understand is that in plan view, 45-degree angle is 12-12 pitch, right? Looking straight down on it. But if you imagine this is the sheeting of the roof and it's at an angle, right? Going up the rake, then, and your sleeper is going up the rake at a 45, let's say diagonally this way. In plan view it'd be 12-12, but it would change as this went up the rake, right? 12 would remain the same. That's really important to understand, that looking down on the plates, in plan view they're going to stay the same, but looking up the rake, it changes. So how much does it change, right? The 12 on the tongue of the square stays the same, but the body of this square changes. How much does it change? And the answer is depending on the pitch. Let's flip it around and pretend this is the pitch of the roof. Let's say it was a 7-12 pitch. It'd be 12 on the level, 7 on the rise, and the hypotenuse would be the rafter for every 12 inches of common rafter run on the level, right? So if we measured the hypotenuse, we would know what for every 12 inches what the common rafter went up the rake. So that is to say, 12 remains the same in plan view, but as you go up the rake, it becomes the hypotenuse of the common rafter with 12 inches on the level, right? So let's say, for example, this was a 12-12 pitch roof in plan view, it'd be 12 inches one direction, 12 inches in the other, and the hip or valley would be running between the two at a 45-degree angle. But with a California sleeper, which runs up the rake, we're going to want to know what our plumb cut is and our level cut, right, down at the bottom. So that would be these two. We're going to want to know what this angle is, and this one here, obviously, clearly it's steeper than 12-12. That is to say, 45. Right? And the other bottom angle is shallower. So what we do is we put the hypotenuse of the common rafter. In this case, I said it was a 12-12 pitch. 12 on the level, 12 on the rise, 16.97 hypotenuse in that case, and 12 on the tongue. 16.97, 12. That would be this upper angle. 16.97, 12. You see that line? This is a 12-12 pitch root. The bottom is 12, 16.97. The top is 16.9712, right? And the bevel at the bottom of it is the pitch of the roof you're landing on. So once you have this line drawn, you set your saw at the pitch of the roof you're landing on. In this case, it's a 12-12 pitch, so you'd set your saw to 45 degrees and you'd run it along a short point along the line that you've drawn, and that'll give you this bevel, right there. And then probably most of you know how to get your jack, right? It's always level. The run is always level, right? But the bevel of the jack, the California jack we call overframe jack, is the pitch of the roof you're landing on. So that's how that goes. I have a quick little mock-up to simplify things. If in fact you were to cut a little scrap of your jack stock, this is a 7-12 pitch. It's important to remember that it's a right triangle. So if you know what the angle of the plumb cut is, minus 90 will give you the angle of the level cut, right? But with the framing square, that's a moot point because it's already given to you, right? Once you have one, you have the other, right? One's the body and the other the tongue, right? Like that there. So if you have that, if you had a piece of wood without any cuts or bevels, you could just slide it until it lined up like that. Drew a line, right? And then set your saw to the pitch of the roof it was landing on. So in this case, just swing it over until that plane's in. Draw a line right here, which in this case has already been drawn. See? Smack it up there, swing it over, because you already have this cut. Swing it over. When it lines up, draw a line, right? Run your saw at the pitch of the roof, at the angle of the pitch of the roof you're landing on, and boom, done. Now, how do you achieve the bevel? The bevel of a California sleeper, for your information, is twice that of the conventional hip. But fast way to do it is just drop it down like that. If you have a scrap of this already cut and you cut this, you can just lay it along there. Draw a line across here, transfer it on up, and do your math for the rise and the run, right? The rise and the run, or whatever kind of calculator you use, or you can take a T-bevel, slide it on up until it's concurrent with the rafter pitch, draw it on there like that, right? like that. Draw a line, make a mark. Transfer that line on up. You can set your saw by eye, or you can take your T-bevel again. But you actually can't take your T-bevel again until you rip it. Use your calculator for your rise and your run. Rip it down. Now, how do you get the length of them? You get the length of them in the same way you get a standard hip length, because it's just a line running across the top of the roof plane. Now, if you lifted the whole thing up with 1/2-inch plywood like we do, it's a little bit more complicated, but I've been seeing a lot of videos on Instagram where you land it right on the frame and run blocks up and down. That way there's no plywooding. Like I said, we need our plywood because it's supposed to create a shear diaphragm that runs up, and we get edge nailing on the ridge and on the block line down at the plate that's transferred down by L50s or A35s down to the wall and then down to the concrete by way of the plywood on the wall, see? So anyway, like I said, once you have that line transferred up, use your rise and your run, or you can use your T-bevel by simply drawing a 90-degree angle on a piece of plywood, running your rise and your run on it, and then taking your T-bevel, putting it on there, sliding it till it's good, or your speed square, checking to see what the angle is, setting your saw to that angle and ripping it. But like I said, how do you get the length of it, right? The length is simply by use the same method as you would use to find your hip length. You'd use the math for that because it's no different. You're going from the outside of the building, on the bottom of it, to where the ridge leaves the top plane of the roof, right? And then not including the deduction, in this case with the deduction, right? That would be this bottom line. Now, if you beveled it, it'd be important that you use the bottom line as the measuring line, and you can cut the whole thing that way, or you can step it off with the framing square. Simply set your square to the pitch of the roof, and then instead of 12 inches like for a common rafter, 16.97, and step it off incrementally, the same number of steps as the common rafter, and then the increments, remainder would be then elongated. But yeah, that's how it's done. And essentially, you achieve your bevel, your rafter length, and then your ridge is straightforward. In this case, clearly these commons are too big. This ridge is probably too small, but it's just a mock-up.